Dear students, you have already learned 2's complement notation to represent integer numbers because we wanted to represent positive and negative both of the numbers. And in today's module, you will learn another notation called excess notation to represent positive and negative numbers. So, similarly to the 2's complement notation, it uses fixed bits to represent each value, and you write down all bit patterns of the same length. First bit pattern having 1 in the most significant bit is represented as 0, and then the following numbers will be representing negative numbers and the preceding one will be representing the positive numbers. So let's have an example. So here we have excess 8 notation, and you can see we have written counting from downward to upward. So when we reached at this particular position where we can see first one in the most significant bit, so here we have stopped, and this value is being represented with 0, and all of the following values are representing positive numbers and all of the preceding values are representing the negative numbers. So if we are using excess 8 notation, this is called excess 8 notation because it is representing the binary 8 to represent 0. So you can you already know that this is 0 in binary 1, 2, 3, 4, 5, 6, 7 and 8. So in excess 8 you are representing 100, which is equivalent to 8, to represent 0, and in excess 16 you would need 10000, which is 16, to represent the 0, and similarly the following will be representing positive and the precedings will be representing negative numbers. So let's see the excess 4 to represent 100 as a 0. So here you can see that we have the excess 4 notation where again we have written from 0 to upward, and wherever we have found this 1 in the most significant bit, that is representing the value 0, and the following one for the positive and the preceding one for the negative numbers. Here I have made a comparison of excess 4 notation for binary, decimal, excess 4 and in 2's complement. So you can see that 111 is represented in decimal as 7. In excess notation it is giving 3, and in 2's complement it is giving -1. You can also understand that in excess 4 notation the value is 4 times more than the actual value, because you know that 111 is representing 7 in the decimal, but in excess 4 it is representing 3. So which means this number is 3 plus 4, that is the actual number 7. And similarly you can say 0 plus 4 is representing 4 actually in the decimal, or in other words you can say whatever is the number in the binary, you can simply subtract 4 from that number and you will get the corresponding excess 4 notation, and similarly you will be getting for other excess 8 and excess 16. So if we summarize today's module, we have learned the excess notation, its representation, and how it is representing positive and negative numbers. How can we convert this from positive and negative and from decimal to binary and to excess notation. And it is very easy to remember that whatever is the number, if it is representing in excess 4, you can minus 4 from that decimal or binary number to see what is being represented in excess 4 notation. And the advantage of XS4 notation will be discussed in next modules when we will be storing the fractional numbers in mantissa and exponent field. Then I will explain its benefit as well, that how the XS notation is being used in computer science.